Welcome to this e-lecture, which will be about inferential statistics. And to give you a sense of what inferential statistics really are all about, well, let's combine the following two elements. We have a sample, and this sample is one of infinitely many samples that could have been drawn from the population. And we want to use that sample to say something general about the population. That's the whole point with inferential statistics. And the sampling distribution is normally distributed, and the standard deviation measures the variation in possible sample results and consecutively says something about the uncertainty of the sample estimates. So since this is just a sample of a population, estimates based on this sample is uncertain, and the standard deviation says something about that uncertainty. So we have two types of inferential statistics. We have estimation, which is to estimate the population parameter, for example a mean, based on sample data. And we have hypothesis testing, which is examine whether an assumption concerning a population parameter gains support in the sample data. So using just a sample, for example, for estimation, we say that this is the estimate of a mean, the mean trust, for example, in the population based on just a sample, and we examine whether an assumption concerning a population parameter gains support in the sample data. We ask if we have a survey of Norwegians and Swedes. We can have tested a hypothesis that Swedes are more trusting than Norwegians, for example, and generalize back to the population. When we do these estimations, we want to put a confidence interval around those estimations, because of course estimations based on a sample is uncertain, as I previously said. Point estimate is an estimation of a parameter, a mean in the population based on sample data, and given the fact that we have sampling error, there will always be a deviation between the point estimate and the population parameter. So there will always be a deviation between our estimate based on our sample and the true population parameter, which we don't know. So we just have a sample to estimate this population parameter. And since the mean then usually in samples usually differs slightly from the population mean, it's risky to base generalizations on point estimates. And to be more certain that we strike the actual population mean, we construct an interval of values that contains the true population mean with a certain degree of certainty. So we construct an interval of values around this our parameter, and say that within this interval the true value in the population is with a certain degree of certainty. And the point estimate, as I said, is equal to the population parameter plus the sampling error. And to be honest about the sampling error, we make a confidence interval. So confidence interval in SPSS, weekly working hours. In this example, the weekly working hours, we have asked people how much they work, and we get a point estimate of 36.157 hours. But since this is based on a sample, on people telling us how much they work, we want to generalize to the working population as a whole. We create a 95% confidence interval around this mean, and we have asked SPSS to make a 95% confidence interval. So the lower bound is 35.86, and the upper bound is 36.46. So it's the true value in the population. The true value in the population is somewhere between 35.86 and 36.46, with 95% certainty. That's somewhere between these and this is the true number of working hours. But our best guess is 36.157. And we could also ask SPSS to make it the 99% confidence interval. We would still get the same mean or the same mean, but we would get a confidence interval which is wider. And this is how the confidence interval is calculated. But of course, SPSS does this for us, so we are the most important thing is to know what the confidence interval is all about. We generalize this to the population, but we also tell that the confidence interval of 95% is this from 35.86 to 36.46. To be honest, that this estimation is based on a sample and thus is uncertain. So that was the e-lecture on inferential statistics. Thank you.